Okay, so today we are talking about properties of exponents. We have x, or a number raised to a power, exponents. Remember, today we're going to simplify expressions using these properties. Your homework is not this. I'm talking to A-Day. A-Day's homework, A-Day, was to do the practice page, which was a handout you received in class, and the fraction side of the other page. Okay, so you have the practice page is two sides, fractions is just one side. Okay, so let's talk about properties of exponents. When we have a to the m times a to the n, two different exponents, but the same base, what do? The property is it's a, same base, to the m plus n. Let's do an example. If I have, so we're just going to be working this way. If I have x squared times x to the 7th, x, the base is the same, these are different, I'm multiplying them, it's x to the m plus n, x to the 9th. Okay, and I'm just going to jump right down to number 3, versus here we have a to the m raised to the n. That is where you would say a to the m times n. So number 3, x, we use the same numbers, to the 2 raised to the 7th power is equal to x to the 2 times 7, 14th. Okay? So those are the differences. Raise it to a power, multiply. Okay, division is, this is a to the m divided by b to the m. So when I have an example, let's do this. Let's say I have 2/3. Let's not use x, let's just use numbers. Raised to the 3rd power. That is equal to 2 to the 3rd power divided by 3 to the 3rd power, which equals 2 to the 3rd is 8, 3 to the 3rd is 27. Okay, and then that's really all I can do. I can't really evenly reduce that anymore. Okay, let's look at when you have two terms multiplied together, both raised to the m. That is equal to a to the m times b to the m. Let's do an example. And I'll use a coefficient and a variable. 3 to the x raised to the 4th power. This is equal to 3 to the 4th multiplied by x to the 4th, which equals, if I take 3, raise it to the 4th power, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, x to the 4th. So that would be my final answer for that one. Okay? Next property, number 5. A to the m divided by a to the n is equal to a to the m minus n. Let's do that. Let's flesh that out. And that will be, let's say I have x to the 5th over x squared. That is equal to x to the 5 minus 2, x to the 3rd. All right, what happens if I have a negative exponent? This is equal to 1, it's the reciprocal, 1 over a to the positive n. Fleshing that out, let's say I have 3 to the negative 2. That is equal to 1 over 3 squared, 3 to the positive 2, which equals 1/9. Okay? All right, last property. Anything raised to the 0 power is 1. So if I have x to the 0 power, it equals 1. Now, how do these work when we're doing a lot of them together? So the properties are fairly easy. Working them out sometimes can be a little hairy. So I am taking this term multiplied by this term. So first what I would like to do, sure, that would be fine. Go ahead. You put it behind my desk. Yeah, no problem. No problem. So first what I want to do is I want to take each variable or coefficient inside the parentheses and raise it to the 4th power. So this is going to be negative 6 raised to the 4th power times x. Now I have x squared raised to the 4th power. So what do I do with that? I multiply them together. That's x to the 8th. Y to the 4th raised to the 4th power. We multiply those together to get y to the 16th. Now I have this term, and I'm going to have to multiply it by this next term. So first, remember, and what we're doing here in raising it to the exponent first is we're thinking about PEMDAS, right? Parentheses, exponents, then multiplication, division, addition, subtraction. So we're not doing the multiplication first, we're going to do the raising it to the power first. So I have negative 2 raised, so I've got to do this term, raised to the 7th. Then I have x to the 3rd raised to the 7th, so I multiply those together, and y to the 35th, okay? So that's step 1. Now, my next step is, first of all, to get these numbers. So let's say I don't know that off the top of my head. So I'm going to go to use my calculator, and I am going to say parentheses, negative 6. You have to use parentheses if you want to use a negative. So raised to the 4th power. Because otherwise the calculator would say negative 6 raised to the 4th power. And anything raised to an even power, a negative raised to an even power is going to be positive, a negative raised to an odd power is going to be negative. So be careful, use parentheses. And then I hit enter, and I get 1296. So this is 1296. So let's just say we've calculated that. Let's do negative 2 to the 7th. Now let's do this. Negative 2 raised to the 7th power. It's a negative number raised to an odd power. My answer I'm expecting to be negative. And it is, negative 128. So this is negative 128. So now I've evaluated those. What do I have to do? I have to multiply this term by this term. So we're going to multiply the coefficients first. So negative 128 multiplied by 1296. It's going to be a big number. So that leaves me with a coefficient of negative 16588. Then I'm going to multiply the x's together. Now this is like x to the m times x to the n. So I add the coefficients together at this point, and I get x to the 29th power. Same thing with the y's, and I get y to the 16 and 35 is 51. So this is my final answer. It's a little bit, so please be slow and steady. Let's do another one. I'm going to raise each individual piece. I'm going to square each piece before I do the division. So this is equal to, what is a to the negative 4th raised to the 2nd power? That is a to the negative 8. b, negative 2 raised 2 is b to the negative 4th. All over, now the bottom and the top are squared, so it's a to the negative 14. This raised to this power is multiplication, so b to the 10th. Now I'm going to a different property. I'm going to a division property. So what is that? This is, let's do it down here, a to the negative 8 minus a negative 14 times b to the numerator minus the denominator, negative 4th minus 10. Please write these things out. Do not try to do this in your head or you will get the signs wrong for sure. So this is equal to a, now minus a negative becomes a positive, a to the 6th power, b to the negative 14. Now that would be an okay answer unless they ask you to write all the exponents as positive numbers, so what I can do when I have a variable to a negative, what happens? It flips, so a to the 6th stays in the numerator, and this is 1 over b to the 14th, so b goes to the denominator. So this is my final answer. All right, so go ahead and give this a try. Okay, raise everything to the powers, then do the multiplication. All right, you guys stop the tape and do that. Okay, and then go ahead and do B and C. Let's do this one together. So left-hand side, sorry. Let's do this one together. So it's hard to read this, but this is a to the negative. Everything is raised to the third. So this is going to be a to the negative 15th. When I'm raising to a power, I multiply. B to the negative 12th over a to the negative 6th, b to the negative 3. I just did all multiplication. Now I'm going to do the division. So this is a to the negative 15 minus negative 6. B to the negative 12 minus negative 3. Please write it out. This is equal to, now this becomes positive, so a to the negative 9th and b, negative 12 plus 3, b to the negative 9th as well. So I can write that as 1 over a to the 9th, b to the 9th. Another way I could write that is I could simplify that one more step, 1 over ab to the 9th, because they're both raised to the 9th power. I do not have to do that last step. This would be fine. Okay? Okay, go ahead and do A, B, and C. So you stop the tape and do that. Now, coming back, when you come back, we can do the same properties with fractions. And this is where we have, again, we get a little more complicated. All right. So we know the properties. Let's just do the examples. So, number 1, my example. Let's say I have x to the 1/2 multiplied by x to the 2/3 power. Now I'm doing the same thing I did before. I'm going to add the exponents. So that's x to the 1/2 plus 2/3. I'm just adding the exponents together. Now when I do add the exponents together, I'm like, oh, fractions. I have to get a common denominator. So I get a common denominator of 6. 3 times 2 is 6, 2 times 2 is 4. 2 times 3 is 6, 1 times 3 is 3. So you just get common denominators. And how do you add them? So this becomes x to, you write down the denominator and you add the numerators to the 7/6. And that is my answer. All right, let's look at the next property. You have a rational raised to a power. So what I'm going to do, let's do an example. Let's say I have 2 divided by x. Now, not just raised to a power, but raised to a fraction. So this is raised to the 1/2. So that becomes, what happens, I have 2 to the 1/2 over x to the 1/2. Now, let's look at what happens. What is it when you have a fraction in the exponent position? This is equal to 2 to the numerator and then the root. This is actually the square root. So see how the fraction breaks out? The numerator stays with the number, so it's 2 to the first power, and then the square root. That's what a fraction is, a root power. Over, and this is just the square root of x, right? X to the first power, and this is implicitly a 2. When we have a square root, we don't write the 2. Okay, so I can just simplify this as the square root of 2 over the square root of x. So that is my function. Let's do the next one. So we're taking the same properties using fractions. So let's say here we have property number 3. So let's say I have x to the 1/2, that raised to the 5/7. Okay, so what am I going to do? This is going to be x, these are multiplied together, to the 1/2 times 5/7. How do we multiply? We just multiply straight across. That's how we multiply fractions. Is equal to x, 1 times 5 over the 5 5th, 14th. Now, just for practice, you can leave it like that, but I want you to show you something that is equally valid. This is equal to x to the numerator, x to the 5th, with the 14th root. These are equivalent terms, okay? All right, let's do number 4. Number 4. Two things multiplied together raised to the same power. So let's take this problem. Let's take 3x, okay, those are multiplied together, raised to the 1/3. All right, this is equal to 3 to the 1/3 times x to the 1/3. Now, we know that fractions are root functions, so this is equivalent to the cube root of 3 times the cube root of x. X to the first, 3 remember the numerator stays with the number, and the denominator goes to the outside and becomes the root function. Okay, so both of those are equally valid. Let's do another problem here just to show you something else. So this is a totally different problem. Let's say I have 27 times x raised to the 1/3. This becomes the cube root of 27 to the 1/3 times the cube root of x. So this is equal to the cube root. What is that? It's asking the question, what number multiplied by itself 3 times gives me 27? Well, 3 times 3 is 9 times 3 is 27. So the cube root of 27 is 3, and then this is x to the 1/3. Okay, I could write a cube root of x either way. All right, let's go on to number 5. Number 5. Two terms where the bases are the same, the exponents are different. So what if I have x to the 4/5 divided by x to the 1/2? Well, this is equal to x to numerator exponent minus denominator exponent. 4/5 minus 1/2. What do I have to do? They're addition and subtraction of fractions, so I'm going to get common denominators. The common denominator is 10. 5 times 2 is 10, so this 4 times 2 becomes 8/10. 2 times 5 is 10, 1 times 5. So now I can subtract those exponents, and it's x to the 8 minus 5, the subtraction of the numerators, 8 minus 5, over the denominator. Now that is the answer right there. Okay, so let's go on to the last one. Let's say I have x to the negative 2/3. All right, so it's the same property. A negative exponent is 1 over x to the positive 2/3. Now I could write this a different way. That's valid. I could also write that as 1 over x to the numerator. This is a cube root, so it's an odd root. Okay, that is my answer. Let's do another one of those. Let me make it a little more complicated by saying x to the negative 1/2 divided by x. We're going to put two things together. X to the negative 3/4. What am I going to do here? Well, first of all, it's going to be I can either work with the negatives, or I can notice that what does a negative exponent do? It flips it. So this whole term becomes x in the numerator to the positive 3/4. And this, because it's negative, goes to the denominator, x to the 1/2. But I'm still left with solving that, so I still have to subtract. But it's a little bit easier this way. X to the 3/4 minus 1/2. This becomes, I have to have common denominators. 2 times 2 is 4, 1 times 2 is 2. 3 minus 2, this becomes x to the 1/4. Or the 4th root of x. X numerator, denominator. So that is our answer to that little problem. All right, it's a lot. We need some practice. I'd like you to try these on your own before you come back to class. Okay? So you have these few problems on our notes. You've got your practice page, and you've got the fraction page. All right, I'll see you in class tomorrow.